Okay, so what do you know so far about, what do you recall just from prior days of inequalities? That's the greater than or less than signs. Any recall? Greater than what? Greater than, less than, or equal to. Okay? So, the first thing I want to just kind of get out of the way is if letter is alone and on left side, then arrow points direction.
And Sarah, I'm going to stop you real quick. Any other missing work anyone wants to show me real quick before I put my book away?
Cool. Thank you. All right, so again, let's focus on what I have printed up there, and let's make sure that we have an understanding of my words. Yeah. Oh, Morgan
Yes,
has stuff for you.
Gotcha, thank you.
So if the letter is alone and on left side, then arrow points direction. Okay. So if letter is on left side and alone, then the arrow points direction. So let me ask you this. Taking a look at problems 1, 2, 3, and 4 that are up there. Is the letter on the left side right now? Does everyone feel comfortable with that terminology? Okay, first one is the second one, the letter on the left side. Look at the problem itself. This is the left side. This is the right side. This is the left, right, left, right, left, right.
No.
What?
Second one, no.
The letter's on the left side.
What's that?
Left side of the problem.
Oh.
Like we have two sides of the problem. So the
they're all
okay. That thank
all
you.
are.
Yeah, they all are. So thank you for saying that. So when I say the left side, the greater than or less than sign acts kind of like an equal sign. Okay? So it says we want to graph the following inequalities. And it looks like we have an open circle and we have a solid circle. Open circle versus solid circle. Okay, so the main thing I want to just make sure this feels comfortable. I can grab my walker away because I can't teach. What I want you all to realize, this is the left side of the inequality. This is the right side. Does that make sense? I'll come over here and point it out on this board too. This is the left side, and this is the right side. And I know it's kind of like, well, duh, that's totally obvious, but I want to make sure you feel comfortable with that terminology before we move on. Okay, so a couple of things. This means you don't include point, and this means you include. Include. I made a better view than that. Okay, so I don't include the point and I include the point. Okay? If you see this sign, if you see this sign right here, that's going to go with these two signs themselves. Greater than or less than. Okay? If you see something as a solid dot, that means that your inequality sign is going to have a little equal sign below. So we're just kind of baby stepping into this. So let's think about this. If I have an open dot, my sign either goes to the right or to the left, and there's not a second equal sign. If I have a solid dot, I have a little equal sign with the inequality sign. Does that make sense? You feel comfortable with how I'm stating that? All right, now, not knowing anything about the problems at this very moment, tell me if it's open dot or closed dot. Open dot, closed dot. Make sense? Would this first one be an open or closed dot? You feel comfortable with that? Confident? It's good. What about the second one, open or closed? Closed. It has the little equal sign. And then open, and then closed. Does that make sense? Okay, so I'm just going to put off to the side that I know that this is an open dot, this is a closed dot, this is an open dot, and this is a closed dot. Is there any part of what we just said that doesn't make sense so far?
No.
You feeling good? Perfect. All right. Okay, we're ready. As long as you have, let's see what I put originally underneath page 65. It says, if letter is alone and on left side, then arrow points direction. Okay. So Stirrup's going to kind of make it a little bit of a mess. Okay. Within this blue region, what I'm going to do is I'm going to draw myself a number line. I'm going to put 0 right here. Hey, question. Is the number 4 to the right or to the left of 0? Okay, so 4 is over here. Hey, friends, did I go 0, 1, 2, 3, 4? Or did I put 0 and then 4? 0 and 4. Okay, now I'm doing that because, one, I would like on any of these problems, unless it's just 0, I want you to have 0 there, and I want you to make sure you're putting your number, your answer, either to the right if it's positive or to the left if it's negative. Okay, so help me out. Did we say problem number 1 was an open dot or a closed dot? Open? We good so far? Look at how our language has gone. Okay? We have our letter on the left side of the problem. We have an open dot. And we have a number line with the number 0 and the number 4. The 4, you having the 0 shows that you understand that the 4 is to the right of 0. And I know it seems kind of elementary to say, they're going, well, duh. But I'm just trying to fill in all the gaps. All right, so this means I want numbers greater than 4. So somebody, give me a shout out real quick. What's a number that's bigger than 4, greater than 4? 7, 8, 10, 5, 4.1. Very good. So, hey, friends, let me ask you this. You've told me numbers that are this way for my number line. Agree? Does that make sense? Now, which numbers are we talking about? Anything that's bigger than 4. Okay, so that means I'm talking about any number bigger than 4. So I'm going to shade the number line this way. Friends, we have just completed our first graphing an inequality. Huh. Between the blue and the pink, I'm going to do our next number line. So let's think about this. I'm going to draw a number line. Still with me? What number do I want to make sure I have on the number line at a minimum? And then is -2 on the left or the right of 0? Do you agree so far with the representation? Friends, did we have a solid dot or did we have a open dot? Solid dot. We have the equal sign with it. All right, now let's think about this. Number 2 says x is less than or equal to -2. So give me a number that you think might be less than -2, which means it's to the left. Yeah. -5. Very good. negative 8, negative 12, negative 255,321.77. Really, that big? Negative 3. Okay, so I want numbers to the left. Friends, we just shaded our next number line.
Also, if you're struggling with the shade and not shade, a lot of times, like how I think of it is like with greater than or less than, it doesn't take a long time to write it, right? Just like an open circle, it doesn't take a long time to write it. Whereas you have greater than or less than, you have to draw that line, and it takes a little longer, and then you fill that circle, it takes a little longer. So that's how I correlate things. So like the full takes longer to fill in, just like it takes longer to write greater than or equal to compared to others, if that makes sense. So little tricks like that, if that helps you, write notes like that. Or if you're struggling with greater than or less than, write on your paper, this means greater than, this means less than. Okay?
So question for you. Less than, what is the very first letter of less than? L. What's the very first letter of left? Right? Left, left. Less than left. But, please, 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 note, if the letter is alone and on the left side, then arrow points direction. Okay? So let's see if you can see, if I can go back, and I'm trying to baby step on this to make sure we feel comfortable with it. If letter is alone and on left side, then arrow points direction. Notice problem number 1, the arrow is pointing this way. Is my arrow on my answer pointing this way? Okay, on the second one, the arrow is pointing that way. So on my second one, is the arrow pointing the right direction? So this statement might make a little bit more sense now. If the letter is alone and on the left side, then the arrow points direction. All right. This one's kind of silly. What number do I want you to have represented? What do I always want to see? But y is less than 0. Do I need to put any more numbers? No. So 0 is going to be on every one of your number lines. On this one, it's actually going to be the only number that we're going to put. Hey, do I have an open or closed dot on this one? Open. And friends, talk to me. Do you think it goes to the left or does it go to the right? It goes to the left, and you're absolutely right saying left. Why are you saying left? And that arrow's pointing left. If the letter's on the left side, that's pointing, that's going to go that way. Okay? Now, some questions come, how much do I have to shade? So I can see a little bit darker going a direction on your number line. So if you make your number line, like as thick as a marker, then you're going to have to use a bigger marker to indicate it. All right, problem number 4, last problem on this page. What number do I want to always have on that? 0. And where is negative 10 with respect to 0? To the left, agree? Notice I haven't written anything more on here. Do I have an open or closed dot? And am I going to go shade it to the right or to the left? And how do you know it's to the right? You're absolutely correct. The arrow is pointing that way. I have my letter on the left side, my variable on the left side, so this is pointing the direction we're going to go. Okay? All right, can we dig a little deeper?
Yeah.
Okay, so this is doing a number line. Agree? Does everyone feel comfortable that there is some sort of number line resemblance up there? No, I didn't go -2, -1, 0, 1, 2, 3, 4, 5. I just put 0 and a number. Okay? Now, this next portion is a brand new idea. Okay? So far, we're good with open dot, closed dot. Agree? feel comfortable that we're shading to the right or we're shading to the left. Left goes with what? Less than. Less than starts with L. Left starts with L. Kind of a good little mnemonic to remember that by. So we're going to introduce something called interval notation. Okay, this is not a number line. This is a representation of what our data is doing. Okay, so we have some little information. It says use parentheses. That means the number's not included, so it's an open dot. So that's the greater than or less than sign without the equal underneath. And then it says use square brackets if the number's included. Okay, before we start going any further on this, problem number 1, do you think it's going to have parentheses or square brackets? Square?
No.
Parentheses. Problem number 2, square parentheses. Excuse me. Number 3, parentheses or square. Problem number 4. Ooh, number 5. All parentheses. Good. So number 5 is going to be a little goofier when we get there, but we'll manage.
Because it's less than or greater than.
Oh, is there a 6 on there? Oh, I didn't realize that. Oh, number 6.
Oh.
Number 6, what do you think?
Oh.
One of each.
Sorry.
You're going to have one of each in some sort of order, but we're not sure what. I didn't realize there was number 6 on there. Okay. So my friends, think about what the number line of x is greater than 4 would look like. You have that kind of visualized? If not, it's back here. It's number 1 right there, right? So notice where it's going. Where's my number on number 1 going? It's an open dot going to the right. Okay? So we're going to start at 4, and we're going to go to a really big number called infinity. Okay? So this means the same thing as this. Those mean the same thing. Interval notation is mathematically more accepted than putting a number line. But how I look at this is take a look at a couple of features that we have up there. We do have our number line represented. Notice I have a parenthesis. Okay, I'm going to start referring as parentheses as soft brackets. Does that make sense? I'm going to start calling the square brackets hard brackets. So we have soft brackets, we have hard brackets. So these are soft. These are hard. Okay? This is our interval notation. This says that the fancy-dancy math smart people stir up British accent people. It's like, oh, our solution is a soft bracket of 4 that includes all of the numbers all the way up to infinity. Is that a British accent?
Pretty good.
It's pretty crappy. We'll go with
Better
it.
than that.
Wait, Master.
Yeah.
Isn't there technically different words and different numbers?
Yeah.
So there's infinite words?
I don't know. You have tons of combinations, but there might be a finite amount of words.
10,001 a word?
Yep.
18 million?
Word.
Technically, there is.
Yeah, I guess so.
9 quintillion?
Yeah.
Like,
Cool.
I'm a genius.
All right. Problem number 2. So I'm going to put what the answer is first. Okay, now let me just pause there. That is indeed the answer to number 2 in interval notation. Now, so a question that might arise, what do you see that is kind of messing with your head a little bit? That I have a negative infinity. That means I'm going to the left forever and ever and ever. But realize on problem number 2, what did we say the brackets should be?
Hard.
They look like all hard. When I look at the answer to number 2, one of them is a soft bracket and one of them is a hard bracket. The reason is, thank you for asking, infinities, I can never get there. Negative infinity, I can't ever get there. Okay? So infinity, if your right hand that you're going to is infinity, infinity will always have a soft bracket. I can't get to infinity. Yeah. Oh, negative, it's all the encompassment of every number. Yeah, but you realize the distance, if you move to the right 5 on a number line, you're still the same distance from negative infinity as you were to positive infinity. If I move 255 trillion, 245 billion, 831 million, 255,021 to the right on the number line, the distance from negative infinity is still the same distance to positive infinity. All right. So let's take a look at number 3. We said soft brackets. Friends, why do you think we are going to negative infinity? We're starting at negative infinity. Because I read interval notation the same way I read a number line. I read from left to right. Okay? If you go into your English class, you read from left to right. You read a text message on your phone that's in English, you read left to right. Agree? And then if you text like me, people are like going, what? What is he saying? I don't even get this. He's dumb. All right, problem number 4. Problem number 4. We're starting at negative 10, and I'm going to the right. What's a number real far to the right? Positive infinity, I have a hard bracket.
Okay, so if you have that and then the negative is going to be either both the same or one of each.
Anytime you're dealing with infinity, you're going to have a soft bracket at the infinity side. Okay? This one has a hard bracket because we had the equal part. Now, take a look at number 5. This is the answer to number 5. This is not a plot point. Okay? And what I mean by that is perhaps in your science class, they'll say, plot the point 5, 7. And you go right 5 on an XY axis, then you go up 7, you put a dot. Negative 2, 4 as interval notation having soft brackets means something, but it does not mean a point. This means I want all of the numbers between negative 2 and 4, all the decimals, all the fractions, everything. Okay, so taking a look at number 5, and I realize this might be twisting around your head a little bit. I can assure you this is not the first time we're going to present it, but we're just trying to build a brain cell or two. Of course, Stirrup's losing brain cells all the time because I'm getting older. All right, my friends. I want a little critical thinking here. I'm going to put 0, 10. Do you feel comfortable where I got the 0, where I got the 10?
Yeah.
My friends, do you think the 0 has a soft or a hard bracket? Hard. Why? Because has the little line, has the little equal part. Does the 10 have a hard or a soft bracket? Done.
There's no infinity.
There is no infinity. Basically, on this number line, this would look like this. 0, 10, hard bracket at 0, soft bracket at 10, shade all the numbers in between. That's what it means. So you're talking about 0.000001, 0.5, 0.8, 1.6.
Wait, so essentially the variable cancels out?
Yeah, you don't need to use the variable. The variable is representing all of the numbers in between. Okay, a little goofier, huh? It's like, stir up, it's Friday. Why did you come in with this kind of information for us? Okay. Can I move on?
Yeah.
All right, my friends. I want to write these in interval notation. So these are already number lines from inequalities. Inequality means we have less than or greater than, could have the equal signs. So problem number 1, where does it start? -2. Where does it go forever? What's the biggest number past +6? Bigger than 7? Infinity. Infinity always has what kind of bracket? Soft, a round one. Okay? I started at -2. I have an open dot. Is it a soft bracket or a hard bracket? Soft. Done. All right, problem number 2. Where does it start? -4. Where does my arrow point to forever? Infinity. Infinity has what kind of bracket always? Soft. -4. Is it a hard bracket or a soft bracket? Hard bracket. You're absolutely right. Why is it hard? You got a solid dot. I love it. Okay. Let's change the smidge. The arrow's going the other way. I know I have a 0 as part of my problem. Where is that arrow pointing to? To the left. And to the left forever is what number? And a negative infinity will always have what kind of bracket? Soft. And the 0 is going to have what kind of bracket? Soft. Okay, now here's where the question comes. Why can I write 0 to negative infinity? No. It needs to go left to right. So you start at the absolute left and read it to the right. So this means I'm going to negative infinity. This means I'm going to positive infinity and positive infinity. Okay? So that's a lot different thought process. All right. I think I'm feeling kind of sort of okay. Hey, let me ask you all this. And this is going to lead into our next transition. This is not too mind-baffling. So I'm 51, okay? So I'm like an old dude. I still feel like I'm 15, though. Okay, that's why I laugh when people fall. Okay? So being that I'm 51 and all of you are younger than that, agree? Now, I realize some of you act more mature than me. Okay, cool. Because I'm not a mature guy. If I'm acting goofy and someone says you're acting like a child, I take that as a compliment. That means I'm young at heart. Is that okay? Now, with that kind of intro, my friends, if, let's say, Principal Silva walked into the door right now
Perfect timing.
That's awesome.
Good job, Carl.
All right. So Principal Silva came walking into the door right now and just wanted to know how many people were here. Even though I'm 51, do I still count as a person? If you're 14 or 13 or 15 or 16 or 17, do you still count as a person? Stone, how old are you?
25.
25? I'm more twice as old as Stone.
My parents are only 3 years older than you are.
Too cool. So Principal Silva came in and just wanted to do a head count. Here you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 24. So there's 24 people he would count if he didn't include himself. Do you agree? Okay, so that transitions us to discrete versus continuous. So discrete counting people. That's an example. Okay? You open up your bag of Skittles. You follow me in this story? You count all of the Skittles that are in your bag. You still understand my story? That's going to be discrete as well because, oh, look, I have 58 pieces of candy, pieces of Skittles. I'm not going to count the crumbs. I'm going to count the Skittles. Agreed? So that's discrete. Then there's something called continuous data. Now continuous is kind of a goofier thought because it's really hard for us to fathom continuous because it's talking about like infinite data. Okay, so you came into this room at the beginning of the period. This room was probably about 78 degrees, plus or right around. What do you think? Okay, so let's say you came into the room and it was 78 degrees Fahrenheit. You still following me on this story? Well, let's say all of a sudden they decide they want to try the heater out in the building. And all of a sudden it's getting warmer. And all of a sudden it gets up to 86 degrees in this classroom. And Stirrup forgot to put deodorant on, so I'm sweating like a pig over here. I stink because you were allowed to make fun of me. All right, now here's the question: does everyone understand the example? The room was 78 degrees when we came in. They decide to turn the heater on. They heat the room up to 86 degrees. So if I went from 78 degrees, the room was, up to 86 degrees, would all of these temperatures in between from 78 to 86, all of the decimals and all the fractions, would they all be taking place? Now, if our digital thermometers usually read to 1 decimal, agree? Yes, they can go a little bit further than that, but if I had a digital thermometer, it'd go 78, 78.1, 78.2, 78.3, 78.4, all the way up to 86.0. Agree? So does that mean temperature grows by a tenth? Or could it grow by 2 decimals, or 3 decimals, or 10 decimals, or a billion decimals, or an infinite amount of decimals? Decimals exist. So continuous means I don't have to take, so here's a really good idea. I heat the room up, we feel it getting warmer. Agree? You're not going, oh, it went up a tenth of a degree. It's like, oh, it's starting to get warmer. If I came into the class and I counted it, I go like this: 1, and then 2, and then 3, then 4, 5, 6, 7, etc. I'm pointing. I have to point. And I know it's rude to point, but let's face it, when you count people, you point. 1, 2, 3, 4, 5, 6. Okay? Discrete means I have to pick up my pencil when I'm counting. My thermometer keeps just increasing. It doesn't go count, count. It goes increases. It has to increase. So continuous data, continuously, you don't have to pick up your pencil when you draw it. Discrete means you have to point to each individual point. So discrete is like a jerky movement. It's like from here to here, from here to here. Okay? It's a jerky movement. Okay, so it's kind of goofy. Now let's go back to here. All right. We want to define the variable, write an inequality in interval notation to model each of the following situations. Decide if the data is discrete or continuous. Okay, so I just said temperature. I said the word temperature. What do you think word temperature is? Is it discrete or continuous? Continuous. So this is continuous data. Okay? If I were to open up my oven before I turn it on, my oven's about room temperature. Agree? If I didn't turn my oven on for a couple days, I open my oven up, it probably feels the same inside the oven as the room temperature. Does that make sense? Close? Pretty close? But it could be pretty close, right? But then I turn the dial to move up my temperature on the oven. So now the oven goes from basically room temperature up to whatever temperature I set my oven at. Okay? So we agree this is continuous. So I'm going to put room temperature to 165 degrees. Now, does anyone know why 165 degrees is why I need to take chicken up to?
No.
164 degrees is where salmonella is killed. The bacteria. Salmonella, you do not want. Don't eat raw chicken. You are going,
I got it. I ate fried chicken and I don't think they cooked
It wasn't cooked all the way through.
Wait, what temperature did they put it on?
I had no idea.
Less than 165. So right now I'm representing the temperature of the oven up to 165. So, but then we need to look at this. We want above 165. I need to make sure I'm at 165, and we're going to go to infinity. You know what happens after we get above the hundreds with chicken? It's gone. Okay? Yeah, you can get your chicken up to 200 degrees throughout. And all of a sudden, it's like eating jerky, chicken jerky. Like,
About 400.
400, man, it might be crunchy. You're going to dehydrate all the moisture out of it. You get up to 1,000 degrees, it's going to like disintegrate.
How about 10,000?
10,000. That's real hot.
Your thing is gonna grow.
All right. So my friends, my bank account can't go below $50. So I can't go below $50. Now, I could have infinite money on there. Now, here's a weird one. I just heard somebody say money is discrete. What do you think? Money does have decimals, so $1.25 is $1.25. Agree? Yeah, I can't go under 1 cent. Good. Okay? So, money is indeed discrete, even though it does have decimals. Okay? If you go over there to the Dairy Queen and you buy yourself that Blizzard, you know what I'm talking about? And you get the stirrup version Blizzard. It's the one where I basically have to climb inside the cup and eat my way out because I like the more ice cream better. Unless I go with my wife and she's like, "Oh, you should get the child size." And I'm like, "What did I do wrong?" No, I want to bring one of those Home Depot buckets. Say, "Can I put a Blizzard in here for me?" Oh yeah. I mean, more ice cream the better. I like Reese's peanut butter cups or Butterfinger. What'd I do? What did?
When you said, peanut, what was it? Butterfingers, you go, like his eyes got so big.
He's thinking about it.
I'm so sorry, but
He's like, I'm bolting off campus, get myself a Butterfinger, Reese's, and everything.
I like Oreo, but I look at this. Oreo is.
All right. All right. I think we're good enough. I think we're good enough. Hey, you guys want a lot of homework tonight? Okay.
Friday. No, homework. I already have so much. No, are you back?
Yeah.
What? You're gonna give us one.
Okay. 67 and 68 odds. 67 and 68 odds.
Yeah, exactly. You're bullying.
Don't tempt us. Okay, if you need a picture, come over here real quick. So that's 50.
Low key.
Oh, that's okay. And it's only